Hello friends, welcome to Basics of Packaging Series Part 3. This part is about packaging materials and their properties. Now the title question: why is plain looking plastic film sometimes a better protector of food than shiny metals or glass? This series is for students, entry-level professionals, entrepreneurs and experienced professionals. Welcome to part 3 of our course on the basics of packaging. In this module, we will explore the most commonly used packaging materials, understand their key properties and learn how to choose the right material from different product types. Material selection is one of the most important decisions in packaging. Why material matters? Every packaging material has unique characteristics. The right material helps preserve the product, extend its shelf life, attract the customer and reduce environmental impact. A poor choice can lead to damage, spoilage or loss of consumer trust. So let's begin by exploring the 5 major material categories. Section A is about plastics. Products made from PET, products made from PE, products made from PP, products made from PVC, products made from LDP and HDP. Introduction to plastic packaging. Plastic is the most versatile and widely used material in packaging, from bottles and pouches to films and trays. It's lightweight, low cost and easily moldable, but not all plastics are the same. Common types of plastics. Here are the most common plastics used in packaging. PET, PET, that is polyethylene terephthalate. It is used for beverage bottles and trays. It is strong, clear and good barrier to moisture and gas. PE, that is polyethylene. It is used for bags and films. It is flexible and moisture resistant. PP, that is polypropylene. It is used for food containers, caps. It is heat resistant and transparent. PVC, that is polyvinyl chloride. It is used in blister packs. It is clear but environmental concerns limit its use. LDP and HDP, low and high density polyethylene, common in milk pouches, shampoo sachet and bottles. Each plastic has different properties suited to specific applications. Key properties of plastics. Plastic materials are selected based on barrier properties against moisture, oxygen and light, mechanical strength, flexibility, toughness, impact resistance, sealability, ease of heat sealing, clarity, important for visibility in retail, chemical resistance, especially in pharma and cleaning products. Plastic laminates often combine multiple layers to achieve a balance of these features. Properties of plastics are depicted in this chart. There are barrier properties, mechanical strength, sealability, clarity, chemical resistance, etc. Choosing laminate structures made simple. Don't miss this video. It could save you time, cost and efforts. Scan the QR code on the left to watch the video. After completing this presentation, you can come back to this slide and scan the QR code and start this video. Grades and types of polyethylene made simple. Don't miss this video. It could help you choose the right material, save cost and improve performance. Scan the QR code on the left to watch the video. Section B is about paper and paperboard. Paper-based packaging. Paper and paperboard are biodegradable, recyclable and widely used for dry goods and secondary packaging. Common types include kraft paper, strong brown paper used in sacks and pouches, duplex board, coated on one side used in cartons, folding box board, also called FBB, high quality board used in pharma and cosmetics, corrugated board used for shipping boxes made of fluted paper sandwiched between liners. Paper is ideal where branding, rigidity or eco-friendliness is a priority. Corrugated board is made by combining fluted, that is wavy paper, with one or more flat sheets of paper called liners. The fluting gives cushioning, strength and stacking ability. The liners provide a smooth surface for printing and additional strength. Picture shows packaging products made from kraft paper, duplex board, folding box board and corrugated board. Strengths and limitations of paper. Advantages: it's recyclable and compostable. Good printability and stiffness. Consumer friendly image. Limitations: poor barrier to moisture and gases, weak against oil and grease unless coated, can deform with humidity. Paper is often laminated or wax coated to improve performance. Section C is about metals. Packaging products made from metals. Metal packaging. Metals like aluminum and tin plate are used for cans, tubes, foil and closures. They are ideal for long shelf life and tamper proofing. Aluminum foil is used in laminate for its excellent barrier properties. Tin cans are used for foods, beverages and aerosol sprays. Metal tubes are common for ointments and specialty cosmetics. Metals offer absolute barrier to light, air and moisture, high durability and strength, recyclability with high scrap value. However, metals are heavier and costlier than plastics and may react with acidic foods if not coated. Section D is about glass. Glass packaging. Glass is a premium packaging material known for purity, clarity and chemical resistance. Common in beverages, medicines and perfumes. It is non-porous and inert. It's available in clear, amber and green tints. It's easily sterilized and 100% recyclable. But it's fragile, heavy and costly in transport. Glass products having different tints. Section E is about flexible laminates and multi-layer packaging. Flexible laminate rolls and pouches. Laminates, combining the best. Modern packaging often uses laminates, combinations of two or more materials like plastic, paper and foil to achieve optimal protection. Example, PET aluminum PE is a common 3-layer pouch. Laminate offering strength, barrier and sealability. Laminates are widely used in snacks, dairy, pharma and personal care packaging. Choosing the right material. When selecting materials, consider nature of the product, solid, liquid, greasy or fragile, shelf life required, cost and speed of production, customer experience, easy open, reseal, squeezes, environmental goals, recyclability, minimal packaging, etc. Material selection affects cost, performance and brand image. Now let's discuss properties of packaging materials. First, mechanical properties. Tensile strength indicates how much pulling force a material can withstand before breaking. Elongation at break shows how much a material can stretch before it tears. Tear strength is the resistance to tearing under force, important for films and paper. Burst strength indicates resistance of paper board to rupture under pressure. Impact resistance shows ability to withstand sudden shocks or drops. Their units are shown in the bracket. Second, barrier properties. WVTR, water vapor transmission rate. It measures how much water vapor passes through. It's important for moisture sensitive products. OTR, that is oxygen transmission rate. It indicates oxygen permeability, critical for food and pharma shelf life. Light transmission opacity. It shows how much light can pass through. It affects product stability. Third, thermal properties. Melting point softening point. It defines temperature range for heat sealing or processing. Glass transition temperature. It indicates the temperature at which the polymer changes from brittle to flexible. Heat seal strength. It shows strength of sealed joints under stress. Fourth, chemical properties. Chemical resistance is the ability to withstand acids, alkalis, oils and solvents without degrading. Migration extractable. It is amount of substances that can leach into food or pharma products. Fifth, physical properties. Grammage basic weight. It is weight of paper, board or film per unit area. Its unit is GSM. Thickness or caliper. It indicates uniformity and strength of packaging material. Density. It relates weight to volume. Affects stiffness and barrier properties. Sixth, functional properties. Coefficient of friction, COF. It indicates slip anti-slip property for machinability. Seal integrity. It determines if PEG seals are leak proof. Adhesion strength, bond strength. It indicates how strongly laminates or labels stick together. The chart shows comparison of packaging material properties like tensile strength, elongation at break and tear resistance. The chart shows comparison of WVTR, OTR and light barriers. The chart shows comparison of heat resistance, sealability, and printability. The chart shows comparison of gloss or clarity, rigidity, and weight. The chart shows comparison of recyclability, chemical resistance, and cost. At a glance, insights about properties of different material. Films win in sealability, flexibility, lightweighting, and clarity. Paper and paperboard wins in printability, cost, and recyclability. Foil is the ultimate barrier against moisture, oxygen, and light. Glass offers premium 100% barrier and infinite recyclability. Now it's time to unpack the truth. Remember the title question. Here is the explanation. That plain looking plastic film is often a smartly engineered, multi-layer sealed, lightweight, flexible, resealable, and tailor-made for food needs, making it in many cases a better protector than shiny glass or metal. Let's recap. Which plastic is used in cold drinks bottles? What are the pros and cons of paper packaging? Why are laminates preferred for snacks? Knowing your material is the first step in packaging innovation and quality assurance. What's next? In part 4, we will explore printing and decoration techniques in packaging, from rotogravure and flexo to varnishes and embossing. Stay tuned to learn how packages come alive visually. Thank you for watching. If you found this video useful, please like, comment, and subscribe. Don't forget to turn on the notification bell. Share and recommend to others who may benefit. Your support motivates us to create more valuable content.